Alright, so this is a video on how to curve sketch. As our problem, we are going to be using 6x over 3x squared plus 6. To curve sketch, we need to find the domain, the symmetry, the asymptotes, discontinuities. So the domain for this particular graph is all reals, since it is not indeterminate anywhere, nor is there a zero underneath the fraction, as demonstrated by Ethan. The symmetry is odd because whenever you plug in a number, the same number comes out should you choose the opposite number, only with the opposite sign. Therefore, as odd, it reflects over the origin, similar to a 180-degree rotation around the origin. To find asymptotes, we simply set it equal to 0 in order to... No. The asymptotes in this particular equation are simply a horizontal asymptote, because when looking at the equation, the highest exponents and the top of the radical and the bottom of the radical, the top is less than the bottom, therefore there's a horizontal asymptote of y equals 0. To find intercepts, you first set the equation equal to 0, and then you fill in 0 for the x variable, and then find the y like that. For this particular equation, the only intercepts we have are at the origin, 0, 0.
Thanks for warning me. Yeah, Gabby went underneath us last time.
Next, we find the first derivative in an attempt to find
Flips over. Oh my god.
extrema.
Sorry. What's the matter?
At this point, it is assumed that anyone trying to curve sketch already knows how to take a derivative, so we will simply just work it out on the screen and allow you to follow along, explaining any strange things about it. It is always important to check your math when doing any sort of calculus, or math in general. Even the best mathematicians must always check their work. Upon simplifying the equation, we find that we can pull out an 18 from the top, as well as a 3 from the bottom. Since in the bottom the 3 is under a squared radical, we must also square the 3 that we pull out, thereby making it 9. Now that we found the first derivative, it's time for us to find the second derivative. We simply do this by taking the derivative of the first derivative, which we just found. When working out problems like these, we often find that even though it may look large, we can cancel out a lot of things. Once we cancel out the things that we can, we find that it often simplifies nicely. Always take your time when doing your math. Better to do it slow and right than quick and wrong. If I cracked a joke, it'd probably be at your expense, so that's me. Recording audio right now, so. Now that we've found both the first and the second derivative, we can find critical points by finding out where the first and second derivatives are either equal to 0 or undefined. In this particular equation, we find that the first derivative is equal to 0 when x is equal to plus or minus the square root of 2. The second derivative is equal to 0 when x is either equal to 0 or equal to plus or minus the square root of 6. Once we find our critical points, we set up a number line for f prime and f double prime. We plot the critical points for both of these derivatives on said number line. We now use this number line to determine the concavity and the slope of our graph. The second derivative is used for concavity, the first for the slope. We can find these by testing any number between critical points. And if we find that what one number is equal to, that will be the trend for every one of those numbers between said points. Because of the odd symmetry, we also find that the first derivative is even in terms of slope, and therefore mirrors itself, while the second derivative returns to odd, and therefore is the inverse of itself. After doing all that, we find our extrema by taking the critical points we found and plugging them in to the original equation to find the y-coordinate. Once we have found both of these, after examination of our number line, we can determine whether they are maxes if it is concave down, or minimums if it is concave up. Points of inflections work much the same, only instead of being min or maxes, they are simply where the equation begins to flatten out in terms of slope, but is still following the same trend. It's also where it changes concavity, but still continues the same slope. Now that we have all the components needed, we can finally begin the sketch of our graph. First, we plot any intercepts that we have found. After plotting intercepts, we plot our mins, maxes, and points of inflection. Then, we look at our asymptotes and we plot those as well. Because this is horizontal, that means that it will approach said asymptote, but it is also able to pass through it. Now that we've plotted all of that, we simply use our points and asymptotes to define the shape of our graph and sketch it out.